here, but as Dion said, my name's Erin. I'm based at the University of British Columbia in the Okanagan campus, but then also working very closely with Lindsay and Dion and also Tara, who's on this call, to make this biodiversity atlas happen. And so, Dion didn't say a whole lot in the first part about this atlas, but basically Lindsay and Dion have had probably more than 80 conversations with folks around this region to really understand what sort of data is available to facilitate that, strategic planning and land use planning, and also what else might be useful in order to facilitate that type of planning. And so from those conversations, they've identified 6 key themes that we'd like to build on over the next year and a half. So for each of these themes, we may develop multiple layers that will help inform planning in this region. So the first is about land cover and also thinking about land cover change going forward. So that's the key one that I'll talk about today. But in addition, we're also going to be working on carbon storage around the region, looking at mapping species at risk, thinking about sensitive ecosystems, hydrologically sensitive areas, and also connectivity between these regions. And so land cover is one that sets the stage for a lot of these different processes. We think about carbon storage and whether an area is forested or agriculture or urban, that really informs how much carbon there might be on the landscape. And so this is land cover change and how we do that from satellite, which then feeds into these other 6 layers that will build up over the next year and a half to make this available on an online platform that anyone can use for their research or also for their planning. So if we think about the current state of what's out there for land use, this map is one from, I'll say, NALCMS, so the North America Change Monitoring System. So it's a layer that's produced across North America, Canada, US, Mexico, at a 30-meter spatial resolution. And so they have many different categories people can use. So if you think about urban or deciduous or broadleaf, but what we've been hearing from folks from those conversations that Lindsay and Dion have had is it's not really at those spatial scales that are useful for making decisions. And so it's not at a fine enough resolution to be able to dial in and say what's happening in this area. And the other piece that's really hard is thinking about those land cover categories that are most important when you're actually making local decisions. And so this one is done at a continental scale. And so it has, some categories. Some of those are not relevant because it has some tropical ecosystems in there. It has polar ecosystems, but also what's really useful for people on the ground in making those decisions. And so that's the key things that we're making a new land cover map to think about, how do we get those useful categories and how do we do this at a spatial scale that's actually informative for planning. So thinking about categories, we've narrowed this down over, iterations of conversations, and it's difficult because, many people want different sorts of things and they might use these maps for different kinds of applications. And so these are a series of categories that we've come up with that might work for most. And so if we think about the top left, these areas in green, so thinking about the vegetation areas, thinking about if we can look at human grassy areas, so that might be soccer fields or sports fields, pasture hay, croplands, also some of these barren areas, and then also different types of urban areas, and then also water-related pieces. So getting at these layers that might be then useful for feeding back into planning. And if we look at then the spatial resolution of what we're trying to build, we're going to use Planet Labs data to get at a 3-meter spatial resolution. So if the one on the left here is the existing map that we can get through the NALCMS layer, then on the right is that kind of spatial resolution that we're working to build towards. So this is a prototype map that we've built with some initial data, and that's the kind of resolution that we're going to build towards. So if there's if a pixel is 30 meters with NALCMS, now we have a pixel that's 3 meters edge length. So basically what we get is 100 pixels for every one that we'd have for the NALCMS data. And so if we just zoom in an area at UVic, so nice because you can see the ring road and see it. So this is an aerial photo on the left where we can see the tree cover, we can see the urban, buildings, we can see the pavement, and on the right, an example of the type of detail that we'd be able to see using this kind of map. So how we're going to do this is using satellite images from Planet Labs, what they call their Planet Scope sensors. What's really great about Planet is first that resolution, so a 3-meter pixel resolution, but also they have multiple satellites in the sky with the same sensor. And so one of those satellites passes our study area just about every day. And so what that allows us to have is a very good temporal sequence of what's happening through the spring. So that is going to allow us to be able to differentiate some of those deciduous trees versus the evergreen trees, as we can see that green up in the spring, and also thinking about some of the other green layers of shrubs, of grasses, and how those change over time. And so the second piece that's really useful is that the BC government has a plan to fly LiDAR data across the province within the next few years. And so far, we have about 60% of that study area has been covered by the provincial's LiDAR survey data. And so that LiDAR essentially helps us get at what the height of the trees or the buildings would be. And so we can use that to differentiate between, what's green and just grassy versus what's green and what's trees, and also between that pavement and buildings, and to integrate into the model. And so then once we have those data, the other piece that we really need is real data on the ground to know what is there in order to train those models. So looking down at the bottom, what we've done so far is look through aerial photos. So ortho images that have been collected by some of the regional districts, using Esri base maps from ArcGIS and also Google Earth Maps, to look at those aerial photos and to have observers sit by the computer and say what we think this land cover is. And so that gives us a category that we can say this is a broadleaf tree or this is a needleleaf tree, to put into a set of data that we use for training and validating our statistical model. And so the other piece that's really key here is actually to get out in the field and figure out what's happening on the ground. So when we look from the air photos, sometimes it's really difficult to distinguish what's a shrub versus what's just grass versus what's a tree. And so having people go out and actually tag what's happening in those locations would be really useful for us in building that really good training data set that we can feed into the model. And for those of you who like the details or who like the stats, basically we're going to use a machine learning model called LightGBM. It's a gradient boosting machine that where we feed in what we'll call, if we have a set of training and validation data, we'll put 70% into the model and then save 30% to then test how well that model is working to see if the categories that the model's predicting actually match up with what we do see in that training and validation set. And lastly, once we build that model, then we're going to apply this across the study area to make predictions for that whole region at a 3-meter resolution. So in terms of the field verification, I guess that's the really exciting part about the community science approach. And so here, I'm just going to move my header so I can see that better. So what we've done is created a stratified random sample across the study area. So study area being in blue, and a lot of these purple dots being areas that we have randomly sampled using the NAL CMS data as a starting point, so that we get all of the different land covers within our training data set so that we can use that for the modeling approach. And so from here, we have these computer records that we have used the aerial photos, and then also the next step is it actually gets some on the ground field data. And so that's where we'd really love some help if anyone is interested in using this approach called Survey 123, where we have observers that go out in the field and actually mark what land use is at these various different sites. So Survey 123 is an Esri product through ArcGIS, but anyone can access it even without a link or an account with Esri. And so what we're doing is currently we're building that survey. It's going to come out in a couple of weeks. So if you're interested in helping us with this project, watch for a link for the survey that Dion will have here. And so basically what this ArcGIS Survey 123 does is allows observers to go out and collect a point, to go into the app to answer a few questions such as, can you submit your location, to press a button to record that from your phone or your tablet, then to identify what the land cover is at that location, giving you an option to add a photo and a couple other questions, and then to submit that record. And the hope is that then with different people in different areas around our study region, we get a really great sampling across space of what's happening in these different areas that we can then use to make these better models. And we're going to have two approaches to doing this. So one is this predetermined set of locations. So if this map here on the left is showing example locations that one might navigate to and then tag it what this land use looks like. So here on the map, some areas in over on the right hand side at Jericho Beach, if there's a grassy area around that area. If we look down to the bottom right, areas in Pacific Park out here at UBC that are reforested, to get a sense as to what's happening across that landscape. And so with this, the Survey 123 in itself is not very good at navigation. It's great at recording. And so what an observer would do if they wanted to follow this stream would be use some sort of navigational assist, like a Gaia GPS, to navigate to that predetermined location, then go on to Survey 123 and tag what's happening. So the predetermined location is great because that gives us our stratified random sample that we can then use for that scientific process. But the other piece that would be really helpful is also just anywhere you choose. And so we can also integrate that into testing that model and seeing how well our predictions match what's actually happening on the ground. So this is an approach where anyone could either use their current location or drop a pin at a certain place and then tag what's happening. And so if this is just an example from Jericho Beach in Vancouver, and so we can imagine you might, if you're out on a walk with your dog, or you're going hiking on the weekend, or you're just moving around the city and you'd like to get involved in the project. And this is a really easy way to take snapshots of different places around where you visit. And so I guess the key here is to select sites that have reasonably similar land cover nearby. So if we look at the picture down at the bottom, there's some trails in there. And so looking at some of those trails, they're very narrow in relation to the size of the pixels that we have. So I guess the key is looking for areas that have, within 3, 5, 10 meters around it, it's all within the same land cover. And so this one would just be really helpful to gather a wealth of data that we can then feed in to see how well those models are working. And so with this approach, if anyone is interested in getting involved, we will have a training session in a couple of weeks once we launch this app to talk about more how that works. But it'd be really great if anyone's interested to get involved. And so for some of these categories, in terms of sampling as well, it's difficult to distinguish categories within each subcategory. So if we look at the top left, those green, leafy categories, or sometimes between that hay, pasture, cropland, some of those similar categories are more difficult to distinguish than the ones that are very different. So overall, basically this layer will feed back into that initial land cover map that we can then use to look at change over time, and then also then feeds back into this carbon storage layer to think about species at risk if we're doing predictive modeling of where species live on the landscape. And then also for these other layers like connectivity, about thinking of how different species might move through these different areas on the landscape. So this is the first step in the process. This is one that we have a community science project right now, but we may also have other pieces for some of these other layers in the future as we develop these pieces. So I guess that's all for my end. This is kind of what's coming. It's going to be online in fall 2025 is when we plan to launch the atlas with all of these layers, but we also may build prototype layers in the meantime while we're doing that. So if you're interested in getting involved in this community science project, there's a link here, the tiny URL, but then also feel free to email Dion or Lindsay or I for any other questions. So thank you so much for listening, and I'm happy to answer any questions or address anything else.
Thanks so much, Erin. That was fantastic. Just to let everyone know, I've put the agenda in the chat, and also we want this to be interactive. So please send in your questions in the chat or put your hand up and ask a question. And we have time at the end as well for discussion. So we'd love to hear from you about the projects that you're doing as well later on. I've also asked Lindsay to ring a bell at 2 minutes for each of the presenters, just to remind them that their time is running out. So don't be alarmed if you hear a bell in the background. So I'd love to hear from questions. Does anyone have any questions? I think
Laurie
has written Laurie, yeah. Lindsay will be reading out the question.
Well, as in, Laurie, do you want to come off mute, or do you want me to read the question?
Sure, I can elaborate over the text that I've included in the messages here. But thanks, Erin. Love the idea of trying to confirm the land cover through the survey process. So I'm just recognizing, of course, that especially in highly developed areas like Metro Vancouver, land cover changes quite rapidly. So I'm wondering if you can provide information in terms of the time frame you're looking for people to complete the surveys.
Yes, that's a good point. So partly it changes rapidly, and what we've seen from some of those aerial photos instantly match what's happening out there today, which has been a challenge in some of that initial work. And then also thinking about land cover change going forward into the future is one part that we'd like to bring in. So perhaps working with Sentinel or other satellites to be able to look at that change over time. So that's kind of a roundabout way of going back to your question. What we're looking to do is over the summer. So we're going to launch this in a couple of weeks in June to put out that survey, to have a session where people can get up to speed if they're interested in working on it, if they'd like to come and learn more about how this process works. And then through July and August is when we'd like people to go out and collect data. And so that'll give us time then to pull back the data into those models and see how well they're working. So July and August would be the key time to get out and do the surveys.
Thank you. And then a follow-up question. I'm wondering if it might be best to focus on the land cover classes where there's typically most confusion with respect to the work that we've done on land cover classification. There's certain land cover classes where there's definitely a lot more confusion than other land cover classes. So it might be best to focus on the ones where there's the most confusion.
Yes, that's right. That's a good point.
Yeah.
And so in some of ours, thinking from just the air photos, distinguishing what's a shrub versus what's sort of natural herbaceous grassy areas versus what's a deciduous tree, those can be really tricky. Also thinking about the hay pasture cropland, those can be tricky to see what's happening. And then also in terms of some of the what's a gravel driveway versus pavement versus soil, those tend to be a little bit tricky. I think the LiDAR will certainly help in terms of some of those vegetation covers. And so in our stratified random sample, we've tried to do more sampling in those areas to try and get at some of those differences. And so people are willing to go out to some of those areas. Part of it, I guess, is also the balance between where people can access and where they can collect data versus where is it useful. And so that's sort of the goal between those two different streams of we have places where it'd be really helpful to get data, but then also getting data anywhere it's easy, it would also be really useful as well. So I think that's a great point of, focusing in on those areas with confusion is definitely going to help build that model. And then hopefully as well, just, bringing people on the process to generate, data wherever is also, useful to some degree, and just, making sure that we're getting the right categories.
Yes, indeed, we've seen a lot of confusion with respect to the barren versus paved and soil, as well as I think there's probably going to be a lot of confusion between cropland and grassy areas. So those may be a couple of good ideas for focusing some effort.
Yeah, it's a good suggestion.
So we've got a couple of questions in the chat, Erin. I've got one here from L. White, so you might need to come off and just give a little bit more elaboration to this comment. But the question is, are you able to leverage the work being done at UBC with multispectral analysis of land cover? L. White, you might want to just specify exactly which project, because obviously UBC is doing quite a bit of work with satellites at the moment. Maybe not able to. Do you want me to repeat the question, Erin, or?
Oh, sorry. I was wondering if L. White was going to come on. So
I think it's Larry, I think it's Larry, but it's in, maybe they're not able to, in terms of sometimes you can't unmute yourself.
Good. Yeah, I guess we're not in direct conversation with UBC at this stage about the analysis of land cover. That's something that'd be quite useful to see what they're doing as well. So far we've basically done the planet scope approach with their multispectral. So they have about 10 different bands that we can use. So I guess the short answer is we haven't leveraged that yet, but that sounds like it could be a nice connection if you're able to follow up with us after.
Yeah. So we just had some clarification. It's around a project that they're doing with the Canadian Forest Service. So it's something that we could follow up and have a look at. Jesse has just indicated that they have a 2023 tree canopy data set. Whoops. It's gone over here now. Hang on 1 second. I've now lost it. 2023 tree canopy data set delineating trees and shrubs, high resolution captured from air photos for the town of Sydney. Would this be a suitable prototype layer to assist with the project?
Yes, that sounds fantastic. I'd be super curious to know how you actually, got from that area to delineate trees and shrubs. But yeah, that'd be really great to be able to see that kind of resolution and figure out, how can we merge that into the bigger project. So yeah, Jesse, that'd be great. Thank you.
And Paul Chapman's posed a great question, which is very relevant to the project in terms of it would be interesting to capture vernal pools, but might it be hard to do? But it might be hard to do in terms of July and August. Will there be other windows to input community info in coming years? So it's kind of two parts to that question in terms of how we're overcoming those issues with our imagery, and then how are we going to overcome that with people on the ground as well?
Yeah, that's a great question. And that seasonality piece has been and will be a challenge through this mapping process. So I guess in the first instance, we're just planning for July and August to develop that initial map. But we are looking to look at change in the future years. And so there may be opportunities in future years to get out and to recalibrate these models. We don't have those plans at the moment, but that is something that, Lindsay and Diane have talked about, is how do we make this an, atlas and these layers be dynamic through time to be useful. So that, the idea of vernal pools, that's one that we have struggled with a little bit, in thinking about, wetlands in general and what kind of seasonality we see. Also in terms of, if we have an agriculture field that's just bare soil, how do we know what crops are there, in the summer months, and also thinking about the snow and ice and rocky areas in the more alpine zones. So that's definitely something that we have had trouble with. The nice part about the Planet data is we can see some of that change with Planet, but the ground truthing part is definitely a lot harder. So I guess that's to say, so far it's July and August. And in addition to that, for the wetlands layer, we might look to pull in the freshwater atlas and some other approaches to look at some of those low-lying areas and to see if we can pick up those signatures of water, in those early spring months.